Okay, students, it's 5.7, power 2. Okay, so last time what you learned was you learned the first power function, which was the derivative of energy with respect to time, right? And from that, you learned four other functions, right? You now know that that energy, whoops, what is that? Energy is equal to the integral of power, dt, right? See if you can remember them as I do them. You also know that power is equal to work divided by time. You know that power is equal to the change in energy. So it could be change in kinetic over time, or it could be change in potential over time, right? So you created these four formulas based off of this one formula, right? Okay, well, how about I mess around with one of those formulas again? Okay, I'm going to mess around with this one. I'm going to show you how it creates another formula, but this other formula is on the formula chart for the AP College Board. Okay, so power is also equal to. Okay, well, we said power is equal to work over time, right? Okay, and we know that work, if you remember what work is, it's force times distance, or another way of writing it, if you look over on the board, on the poster, work is equal to the integral of F with respect to R, right, which is distance. But you can just rewrite it as F times D, D meaning distance in this case, okay? Now, what I'm going to do is I'm going to focus on splitting this up, so I just do that over that. So we can rewrite this as force times distance over time. Distance over time. That reminds me of a formula we know. That's the same as velocity, right? Okay, so we have a new formula now. We have power is equal to FV. Okay, F times V. Now I'm going to pause you for just 1 second. Okay, so here we are on the formula chart, yeah? Okay, so this is the power ones. We got power is equal to the derivative of energy with respect to time, and we got this one, power is equal to F times V. Now you're looking at that dot. If you're looking at that thing, you're like, wait, there's no like multiply dot in between any of these other letters anywhere, these other variables. Why is there a dot on this one? You know? So I will get into that in a little bit. But let's first, we call this dot product. And if you see these two arrows above that, the variables, remember that means that those two things are vectors, which means they have a direction and a magnitude, right? So whenever you have two things that have direction and magnitude, if they're not working in line with each other, that means that in order to put them together, you kind of need to use some trig, right? So let's look back at this. Okay, so what we have here is we have power is equal to force times velocity, right? Force times velocity. And I should put up a new poster for that, okay? Force times velocity. So all that means is if I give you anything to calculate power, you're going to be doing force times velocity. So let's look at the worksheet real quick a little bit. Okay, so during some time interval, the constant force delivers an average of 5 watts. Okay, that's power of an object. If the object has an average speed of 2.3 meters per second, okay, that's velocity, and the force being acted in the direction of motion, and the force is acting in the direction of motion, what is the magnitude of force? So you can just use that formula right there, right? You have power, you are looking for force, and you have velocity. Okay, looking at this one. If the force of an object being pushed is given by this, and the position is given by this, calculate the power being used at 1. Okay, so you have force and you have position. Well, that makes it a little weirder, but from a position formula, you should be able to get velocity, right? And if you don't remember how to do that, just look up on the board. It's the PVA. It's the very first poster up there. Okay, and then you can just, if you want to figure it out at 1, that's telling you to plug in 1, right? Now here's the thing though. I want to make sure that I teach this in a calculus way, okay? If force is, so right here, if force is acting on an object, if force of an object being pushed is given by, and the position is given by, and then what this should really say in here, and force and velocity are in the same direction. Calculate the power. Now, I want to show you how to do it if it's not in the same direction, okay? So, if there's some object and it's moving this way at like 2 meters per second, and somebody pushes it this way with like 5 newtons, yeah? Well, that doesn't even look like an S. What's going on with my letters? Okay, 5 newtons. And it says calculate the power. Well, you would just say, oh, well, I'm going to do force times velocity. I would do 5 times 2, and that would give me 10 watts. I know that the power that this thing is producing is 10 watts. Yeah? Now, but here's the thing. What if the object is moving like this at 2 meters per second, and somebody pushes it like this at 5 newtons? Yeah? Then the power, it doesn't increase. The power of this doesn't increase at the same magnitude as it did on this one, right? Because you're not pushing it in the way that it's moving, right? The power is kind of not in that direction. So what would happen here is if the object was moving like this and you push it this way, the object's going to begin to start moving, more towards, the right instead of like at that exact angle right there. It'd start moving more like this, like this, like this as time went by, right? So if you wanted to calculate the power an object has like this, what you would need to do is you would need to know the angle between them. Yeah, so let's say the angle here is like 55 degrees. And they said, oh, calculate how much power the object has at after when this force is being applied to it. So here, that's what this dot is. Okay? Whenever you have two vectors and you want to multiply them together, there's two different ways. There's the dot product and there's cross, okay? Now, I didn't really go into vectors very much because the AP exam doesn't really use them very much. But I know you guys are taking calculus-based physics, and I want to make sure to hit on everything here in case you run into it. Okay, so this dot means it's force times velocity times cosine of the angle that's between them. That's what this means. That's what the dot means. So if you were going to do this, it'd be 5 times 2 times cosine of 55. And then you would just type that into your calculator, and you see how it's probably going to be smaller, right? 10 times cosine of 55, and it comes out to 5.73. So the power is going to be different on this one than this one if they're working in the same direction. Yeah? Okay, so that's what this little dot means when you look at it on the formula chart. Okay, that's what that thing means. Okay, and then let's just go back here and look at some more of this. Okay, to the right is an energy time graph. Okay, now remember, here's what you should think when you think energy time graph. Okay, an energy time graph, the derivative of it tells me power. Yeah, derivative of that tells me power. And you should know what derivative means on the graph, right? So calculate the power at t equals 5. So that would be like right here, right? Calculate the average power from 6 to 8. Remember average? What does average mean? That means that you're using 2 points to get something. It's not like average when you're trying to calculate your average grade and you have a bunch of grades that you're going to try to put together. Average on this in physics means you got 2 points and you're going to use those 2 points to figure something out, like the slope, okay? Calculate the power of the object at t equals 1, okay? Calculate the velocity the object is... calculate the velocity the object has or is being lifted at t equals 1. Okay, the velocity that the object's being lifted at. Okay, so if you're messing around with that, just remember power is equal to force times velocity, right? Okay, well here there's no forces given, but you are lifting a 3 kilogram object, right? So how much force does it take to lift a 3 kilogram object? Okay, that's what you need to think about. And think about what force is. Think about force is mass times acceleration, right? And you can switch that acceleration for something that might be fighting you as you try to pick something up, right? Okay, and I feel like the rest of these are pretty similar to the ones on top. here an engine is moving with a power, so it gives you a power. Oh, I remember writing this one. Okay, so it gives you a power formula, but in that power formula is a velocity, right? It's a v. And if the position of the object is given by this, so you have a position function, calculate the energy used in the first 3 seconds. Okay, so that one's a creative one. It wants you to calculate energy and they give you power, right? Okay, so let's go back to our old stuff. Calculate energy given power. So it's going to be the integral of the power formula with respect to time. So here, if you do this, it doesn't have time in it, right? But you can figure out the velocity formula with this function and replace that v with an actual formula that has time in it, right? And then you can go about doing, the integral that you need. Okay, and the rest of these are, let's see here. A crane is lifting an object to the roof. The object has a mass of m and lifted a 4h up to the building at a time t. Calculate the power generated by the crane. Okay, so remember, I'm going to say you're going to use one of these. Okay, I'm going to tell you you're going to use one of these to calculate that. That's not the force equals velocity times time. The crate then is lifted an object to the 3m. Okay, so you would want to use that exact same formula, whatever formula you use for the part A, you would use for part B, and then you would compare what they look like, okay? The kinetic energy of an object from a conservative force at x equals 0 is 10 joules. If the potential energy is given by this formula, calculate the total energy at x equals 0. Okay, so you know that the kinetic energy at 0 is 10. So if you can figure out what the potential energy is at 0, you can put them together, right? And then you would know the total. Okay, and from that stuff, you should be able to figure out the rest. So good luck. I hope you have a great weekend. See ya.